Hi there. Today we're looking at quadratic functions in vertex form. And the first thing we're going to talk about is what a quadratic function looks like. When we graph a quadratic function, a quadratic is just a function that has an x squared term in it. And when we graph a quadratic function, we end up with a parabola, which is this U-shaped kind of curve. And anytime we graph a quadratic, we're going to get this U-shaped kind of curve. So that's what we're looking for when we graph these things, is a parabola. The most important point on a parabola is the vertex, and this is the maximum or minimum point, or the highest or lowest point. And really, it's kind of where our parabola originates when we start to graph these things. So the vertex is that most important point. Everything's going to kind of revolve around that vertex. The other thing that we have that helps us graph these things is the axis of symmetry. And this is a line that divides the parabola into two matching halves. And it always goes through the vertex. That's the other important thing about the axis of symmetry. But basically, the axis of symmetry kind of acts like a mirror. All right, that kind of cuts the parabola in half, and we have a mirror image on each side of this thing. And again, it always goes through the vertex because the vertex is at the center of this thing as well. All right, when we graph the axis of symmetry, we always graph the axis of symmetry as a dotted line because it's not really part of the graph of the parabola. It's just there to assist us in graphing the parabola. Okay? So again, let's look at the most basic form of this thing. The most basic function that we have here is y equals x squared. And the way we're going to start off graphing this thing is we're just going to set up an xy chart. So we're just going to plug in a couple values. Anytime I'm doing an xy chart, I always start with these typical values, -2, -1, 0, 1, and 2. Because it gives us a good mix of positives and negatives. It also gives us the value of 0, which is always good to have, and see what it looks like. All right. And so I just plug each of these in for x right here. So I'm plugging the -2 in. When I plug the -2 in, it gives me a +4. When I plug the -1 in, it gives me a 1. Plug the 0 in, I get a 0. Plug the 1 in, I get a 1. Plug the 2 in, I get a 4. All right. And so as I graph these ordered pairs, I've got, let's see, the -2, 4 is up here. The -1, 1. The 0, 0. And as I plot these things, I kind of get this thing. It almost looks like a V, but it's not. I know it's got to be a parabola. This is an x squared, so it's a quadratic. So I know it's this U-shaped kind of thing. That was terrible. Let me try that again, because I just can't live with that. That's much better. All right, so we get this kind of this U-shaped figure, and as we look at this thing, we want to identify the vertex. Well, the vertex is the highest or lowest point. In this case, I've got a low point right here at 0, 0, so that's my vertex. So my vertex is 0, 0. And then the axis of symmetry, if I were to cut this parabola in half, there would be a line right here that cuts this thing in half. That's my axis of symmetry. My axis of symmetry is the line x equals 0 for this one. And again, a couple neat things about this is, one, the axis of symmetry cuts through the vertex, and it's a vertical line, so it's x equals. Well, that means it's just x equals whatever the x value is from the vertex right here. That's why it's x equals 0. All right, and so we see a couple neat things about this. The other neat thing here is we look at the y values on either side of this vertex. Since the vertex is this point in the middle, we can see that even the y values are symmetrical in terms of the values in my table. All right, but this is our basic, most standard graph of a parabola is the y equals x squared, and every other parabola is going to look kind of like this guy, except it might be moved around or shifted or stretched vertically or shrunk vertically. And so that's what we're going to look at as we start to graph these things. So the way we're going to approach this is vertex form, and we start off with vertex form because this is very similar to what we did with vertex form with the absolute value. If you think about the absolute value, the vertex form for that was y equals a times the absolute value of x minus h plus k. And where hk was the vertex, well, here hk is also the vertex. Remember, we have to do the opposite of that h value and take the k value exactly the way it is. The a value is going to have the same effect. Remember, in this guy, the a value is stretching us vertically or shrinking us vertically, which would kind of affect the slope of the v shape. And it's going to be the same thing here. That a value is going to stretch us or shrink us. The a value being positive or negative is going to tell us whether this thing opens up or down. So we're going to approach this kind of the same way that we did with the absolute value. And so, for example, if I look at this first guy, Again, I'm going to identify the vertex, I'll identify the direction of opening, that kind of stuff. So when I look at this thing, I've got my h and my k, and since I have a -1 here, my h value then is a +1. Because remember, we always take the opposite of what that guy is doing. And then my k value here, I've got a +2, so it's going to be a +2 because we always take the k value exactly the way it is. All right, so I've got my vertex. The a value right here is a 1, which is also going to help me in the graph. So we can see this thing in vertex form. We see all those pieces. The axis of symmetry, again, it's going to be the equation of a vertical line. It's going to be x equals 1. And the reason it's going to be x equals 1 is because it's a vertical line that has to pass through the vertex, and the vertex has an x value of 1. All right, so it's going to have to be x equals 1. And you'll see that when we graph it as well. And so when I go to graph this thing, I've got this vertex of 1, 2. So 1, 2 is right here. And since the a value is positive, I know this thing is going to open up. So I know this thing is going to open up. And since it's a +1, it's going to be my standard width. And when I look back at the previous example, this is my standard width. So this is showing me what my standard width is. And so if I use this as a template, you know, if I've got my vertex right here, my first point is over 1 and up 1. My next point is over 2 and up 4. And I can follow that same template here. If I have the same size and shape as that guy, my first point would be over 1 up 1 from that point. My second point would be over 2 up 4 from that point. And I can do the same thing in the other direction, and it kind of gives me this U shape. And again, it's the exact same shape as the one above this, but it's been shifted and moved a little bit. And so I can see that kind of standard shape. It stays at that same width that we had it before, all right? And so we're applying those same rules, and really, again, when we looked at absolute value functions, those same rules applied to every function, and here they are. Okay, when I add or subtract on the inside, it moves it left and right, and it's always the opposite direction we might think. When we add or subtract on the outside, it moves it up or down, and then that a value affects the shape of this thing, how wide or narrow it is. All right, and so we've got this quick graph, and we can also see the axis of symmetry right here. There's that vertical dotted line, and we can see again these points are reflections of one another. So this point is reflected over here, and this point is reflected over here. All right, so it makes these things fairly simple to graph because they're symmetrical. Okay. If we look at another one, if we look at something like this guy, this time we're changing the a value. Again, my vertex, when I look at the vertex for this one is going to be -1, -3. So that's my vertex. The axis of symmetry is going to be x equals that x value that's right there. So it's going to be x equals a -1 this time. And now we can see this thing's got an a value of +2. So we'll see how that affects the graph in a moment. And so when we look at this thing, we've got -1, -3. So I go -1 down to -3. This thing is going to open up because my a value is positive. And so now if I think about my standard graph was over 1 up 1 over 2 up 4, my standard width kind of looked like this. All right. But this one's not going to be my standard width. This one has an a value. Again, the a value here is 2, which means this thing's going to be stretched vertically, which is going to make it look skinnier. And so what happens, because I'm being stretched vertically by a factor of 2, so right here, instead of going over 1 and then up 1, I'm going to go up 2 instead. I'm going to go up twice as high. So this thing's going to be stretched vertically. And I'm actually going to point a point here instead. Instead of going over 2 and up 4, I'm going to go over 2, and I'm going to go up 8 units. Because, again, I'm stretching this thing vertically. And if I think about my axis of symmetry here, my axis of symmetry helps me reflect these points. So I'd have a point here and a point here. And so what I get is I get this really skinny parabola that looks like this. And so when I compare that to the green, I can see that it's skinnier because it's being stretched vertically by a factor of 2. Okay, and that's really it. That's what we're looking for when we do these. If I clean this up a little bit and I get rid of the green parabola, because really that was just helping me see that this thing's going to be a little bit taller and a little bit skinnier when it's all said and done. And there it is. All right, and again, we do the best we can trying to make this thing look like a curve. All right. If I look at the next one, again, the vertex, I'm going to do the vertex. The vertex looks like a -2, +4. Axis symmetry is going to be x equals a -2. And this time I can see my a value is a -1/2, so that tells me a couple things about this. But as I look at this thing, -2, 4, -2, 4 is going to be right here. The axis of symmetry, I'll go ahead and draw that a while because it makes it a little bit easier to graph this thing. And now my a value being a negative 1/2, that tells me a couple different things here. First of all, it tells me that this thing's going to open down because it's negative, and it's going to be half the height of my standard width parabola. So again, my standard width parabola would look like this. All right, this is the one that I've drawn a couple times now. I'm basically copying the same template or the same pattern from the first one. That would be the standard width. Well, this one's going to be half the size. In other words, right here, instead of going over 1 and then down 1, I'm going to be going over 1 and only down half that much. So I'm going to be going down a half. So if I go half of this thing, it looks like this. Here, instead of going down 4, I'm only going to go down 2. All right. And again, I can use my axis of symmetry to kind of mimic this thing on the other side. And so what happens is I kind of get this parabola that's very similar, but it's wider. So I get this wider shaped parabola. I can get rid of the green one again. But that's what a 1/2 does. Remember, when we have a fraction there, it makes this thing look wider because it's being shrunk vertically. And that's it. All right, so that gives me kind of a quick sketch of these things. So we're plotting the vertex and then using the a value to determine the direction of opening and how wide or skinny this thing is going to be. And so when I look at something like this, for each of these, I want to identify the vertex and the axis of symmetry for each of these, and then we're going to see if we can write an equation. Some of us might be able to do this and some maybe not. So when I look at this first one, the vertex right here is the high point that's right here. That looks like the ordered pair 3, 0, so it looks like, or sorry, 0, 3 right here. So my vertex on this one is 0, 3. The axis of symmetry is then x equals 0 because it's got to be this dotted line that's going right down here through the center. And so now if I wanted to write the equation of this thing, really all I need is the a value, and I can see that this thing opens down. So since it opens down, the a value is going to be negative. And then is this wider or skinnier than my original? Well, this one's a little bit skinnier, and look at the pattern that happens here. When I go over 1, I only go down just a little bit. I can't really tell where that is. But here I can tell with the next one. When I go over 2, I go down 1. Well, normally when I go over 2, I would go down 4. So since I'm only going down 1, I'm going down a fourth of that. So my a value is actually a negative 1/4 here. And if you don't quite see that, that's okay. But you know, think about that in terms of the pattern. This is 1/4 of the size. So the equation for this one would be y equals a negative 1/4, and then x minus 0 squared plus 3. And so when we clean this up a little bit, obviously the x minus 0 I can just write as an x. So it's just x squared and then the plus 3. And that's it. So it's relatively easy to come up with the equation if we got the vertex and if we can kind of figure out the a value based on how wide or skinny this thing is. Okay, this thing's been squished vertically. And again, if I look at the next one, I can see my vertex is right here. That looks like the ordered pair 1, negative 1. And so I've got my vertex here. My vertex is 1, negative 1. My axis of symmetry is x equals that 1. And again, I can see that if I draw that line. And then when I look at this thing, does it have my standard width? I go over 1, up 1. I go over 2, up, looks like 4. And so that's my standard width of my standard parabola. So the a value, it opens up, so it's positive. It's got my standard width, which is a 1. So again, we're following the same pattern that we followed when we talked about absolute value equations. And so this one, it's y equals a, which is the 1. I don't even need to write it. X minus h, which is 1 squared, plus k, which is the negative 1. And that's it. So I can kind of see how the vertex and the a value not only give me the graph, but work in correspondence with the equation as well. All right?